Welcome back, everyone, for another round of sessions where we are going to talk about intelligent waste management. And for that, we have industry experts and leaders with us joining. We have Mr. Shantanu Gupta, who's a Chief General Manager from Indian Oil Corporation Limited. We have Mr. Sandeep Dave, who's a manager, head of director of business development for Abellon Clean Energy. We have Mr. Suhas Baxi, who's a CEO for Biofuel Circle, and very soon we have Mr. Nitin Shete, who's a vice president for Praj Industry. And along with that, we have one more speaker who will be joining us later. So to start, I would request Mr. Gupta to start the session, and then we continue with our other respective speakers. A small request, since it's a 20-minute session, I would request all the speakers to keep their presentations a little crisp and strict to 20 minutes so that we can hear it from all the speakers at a given stipulated time. Over to you, Mr. Gupta.
Thank you very much. Very good morning to all of you. Nice talking to you and connect over this virtual platform. I will speak about some initiatives which are being taken by Indian Oil and on this very, very important field of waste. So, ladies and gentlemen, and all the eminent speakers present here. So, I'm Shantanu Gupta from Indian Oil. I will just speak about intelligent waste management from our perspective. So what are the motivations? You will see that why Indian Oil suddenly, in the oil company, giving the oil domain, having a very comfortable area of market leaderships, why suddenly this thing? See, we have been doing the oil business for over 60 years today in the country, where leadership positions we have gained over a period of time. Now the time is there where we have to definitely be more focused. We had been doing this focused sustainable development issues and alternatives and efforts being taken from all angles to make that carbon mitigations. So these are the motivations that are coming along with the time. First off is energy transition, then climate change and green economy, then import dependence reductions. You can understand the amount of, we are over 85% import dependent still now for the crude oil. And then Swachh Bharat. So then all four areas which we feel we need to address and which we'll have in a better method, and we can develop methods which will add to our business lines also. Not only that, it's not only a profit method, it's also giving a big self-reliance for the country, Atmanirbhar Bharat. Coming to the Earth Overshoot Day, I just wanted to give you a very snapshot, very interesting phenomena this is. This is being measured, and from say 1970 to 2020, we can see what does it mean that Earth Overshoot Date is the resource demand exceeds Earth's biocapacity. It's like you have a family, you have a monthly budget. Now your budget ultimately your cost exceeds your budget. So within a matter of say 21 days or 32 days, you spend everything. So last 1 week, you don't have anything to spend. So Earth is also having a capacity, and this resource demand within Earth's biocapacity, which is the culmination of our development hunger, the thirst for getting more and more. This is pushing us very hard. You can see 1970. If you see a calendar year, the whole resources from 1st January 1970 to 31st December 1970. Up to 29 December, Earth could support. 2 days we have to borrow. Borrow means there is no other planet. So we have to exert this planet, we have to squeeze this planet. Similarly, from 1980, it came up 4th November, 1990, 11th October, 2023 September. See, it is shorting out. That means we are consuming much more than what Earth can provide to us as a mankind. Interesting thing happened after 2019, that 29 July, that means to survive, we need 1.6 times of an Earth to supply, to maintain our supplies, to maintain our life livings. Now 2020, very interesting thing happens. You have all the answers. This is a COVID diet, whatever happened during this period. Earth became totally silent. All activities got paused. So 29 July, which was last year, now it is 22nd August. That means it's almost 3 weeks extension COVID has given. That yes, you were living, otherwise you could have been another 1 month back. We could have landed at the month of June, completely exhausted. But it has been pushed to 22nd August. That means we get some extra time to survive. So, with having all the negatives of COVID, it's a big positive because Earth got to take some rest to recharge itself. The Mother Earth recharging. Because the way we are torturing the Mother Earth, it's an indication of that. So, coming here, this needs that there will be serious looking into that, what exactly the desire should be for mankind. From there, straight I am coming to West in India. Why and what is this problem? You can imagine the numbers, mind blowing. 62 million metric ton, which is waste generated every year. ICRIR New Delhi is projecting at 2017 data 72 million metric ton. So anything around 70 million metric ton. This is going to become 165 million metric tons by 2031 and 436 million metric tons by 2050. So our country, the Mother Earth, is ultimately getting covered with waste. And this waste is in the component, which is a composition. You can see the pie chart. Organic waste is around 51%. Inerts and others is 32%. Paper, plastic, another 17%. So this is roughly the estimates. It varies from the zone to zone, but more or less plus minus 3 to 4%. It remains in this order. You can see the heaps, the photo of the heaps, which is the waste we are throwing. Every household, every individual is throwing every day. Sewage treatment waste. This is another waste which we are getting at data's total urban waste generated for 36,000 million liter per day, and it is having 816 sewage treatment plants in the country. So we are treating around 23,000. So about 50% of the STPs have digesters, biogas. So these producing facilities are available, but need to lot of work to revive and make this productively used. Namami Ganga is the one area where they are working on this. Another issue is very challenging issue is crop burning in India. You must be reading through the newspaper, seeing in the video, medias and all those things. See the spots, red spots, which is the where the parallel burning is taking place. 26 May 2019, you see, this is we are trying to capture during the winter and during the summer. Majority of the paddy straw is burned in the field. Total dry mass generated, you see the number, 682 million metric ton. Surplus crop residues 179 million metric ton. Out of that, 140 million metric tons to the tune of is being burnt every year. Just imagine the amount of pollutions is coming out. Instead, if you can use it productively, you can really generate energy. We'll come in that later. Biomass, which this is the surplus crop biomass. These are the major sources. Cotton 17%, rice 24%, and sugarcane 23%. So these are the major contributor for biomass. And what can the use of this biomass? CBG, that is compressed biogas, ethanol, it can be produced from lingocellulosic agriculture residues such as rice straw, wheat straw, and bagasse. 11 major crops are available in India. You can see that. Surplus biomass available 178 million metric ton. And if you convert this, the product, this potential of ethanol potential is 550 billion liters of ethanol can be produced by using different technologies. And also, you can have a production of CBG potential of 18 million metric ton by using this, which is over 50% of our gas requirement. Coming to the option 1, we can see that compressed biogas option, which has become very, very handy and very, path-breaking initiative by government of India. This is basically what? Basically, this is methane, and it is mixed with carbon dioxide and H2S. So what we do, this contains CH4 at 50 to 60% level. Then this is being enhanced. Then it is being purified and then compressed. And this CH4 compressed biogas contains methane over 96% methane. Then it is sold as a automobile fuel or for industry. Both are ways this is the possible. This is briefly the schematics of the CBG production and the use and applications. See the left, animal dung, cow dung, then biomass, sewage treatment plant, municipal solid waste. This all organic waste after pre-treatment can be digested. In this digester, there are different methods of digestions. Then this can be produced, biogas can be produced, and this biogas then purified through the process. CO2 and H2S are relieved, and then it is compressed as per the IS specification when it meets IS specification. Then these are the small cylinders, which you know the cascades, and these cascades are positioned at various gas stations, outlet what we say here in India, petrol pumps. There, these facilities are being created for dispensing to the motors. So this is the process of delivery, what I talked, process of CBG production from production to ultimate delivery to the customer. This is the gas flow from top after digestions, biogas and purification compression, then transportation. And then bottom, it is very important, this is digested, which is biomanure and slurry. This is also a very, very useful fertilizers, which is produced as a byproduct for this. So these three products, biomanure, solid, bioslurry, liquid, and compressed biogas. Three products are available from this. The whole waste has been converted to valuable product. Technology-Digestions, this is the technology for digestion. Anaerobic digestions is taking place. There are wet digestions. There are two types of that CSTR, which is continuous stirred tank reactor, and then it has a plug flow reactor. So these two methods are widely used. And then dry digestion, there is a garage type reactor. This is also very limited use, but in Germany and other European countries, this method is also applicable. These are the technology for digestion. This is a daughter booster CBG station. You can have a flow CNG trailer like CNG, the same method we are writing. I have kept CNG because this is the flow of compressed natural gas. Similar way it can be because it's a competitive fuel, you know. CNG and CBG, there is no difference, absolutely no difference. There is no additional fittings required for many vehicles. If you top up with CNG, it can be replaced with CBG at any point of time and vice versa. So similar model is being used here. You can see the compressor, the cascades, and then the refueling to the vehicles. So this is how CBG can mitigate dependence on imported fuel. Natural gas imports and biomethane production. In 2040, you can see this is the way it is going to happen. An import bill saving from biomethane. This is three countries, if you see, they are working very, very intensely. The European Union, China and India. So you can save billion US dollar to the extent of 10 billion US dollar. If you see this happen in India, which we are starting now, 2018 1st October, the Satat program was launched, which was sustainable alternative towards affordable transportations. Through this, CBG is being spread. We have a target of 5,000 such plants to come to the country, which is the slide now it is speaking. This 5,000 plants by 2023, which will producing 15 million metric ton of CBG and 50 million metric ton of biomanure. See what is done. We have fixed the price as 46 rupees per kg and taxes, which is 5% GST now. This is up to 2024 March. And then this price becomes floor price. So it becomes minimum price. And for next 5 years, it becomes floor. So anything over and above this will be applicable based on the market situation that time. So that is the price visibility for 10 years up to 2029 price has been guaranteed. And so far 621 letter of intents have been awarded, which is equivalent to supply of 1.25 million metric ton per annum of CBG. So out of 5,000, we have achieved 621 letter of intent. Now materializing letter of intent, there are certain issues which are coming for the feedstock biomass supply chain. The other expert is sitting here. Technology provision, because as I say, we are taking baby steps. It's a very initial period. There will be issues. There will be policy intervention required. And those things once placed, it will have a huge future potential for this country. We are branding it started out of total 13 refilling stations. We have started selling CBG, which is through under this IndiGreen brand. which have been developed in-house. These are the few of the photographs. This is the first came. This is the Pune, Maharashtra, which is 2 retail outlets have been attached to this plant of Noble Exchange. It started from September 2029. This capacity is 14 ton per day CBG they can produce. So this you can see the retail outlets, these vehicles are being refilled. Kolhapur, Maharashtra, it was the number 2 in the seniority. It came in the existence from 12 September 2029. 6 ton per day is the CBG production capacity. So you can see a bus is being refueled there. Then we came to Namakkal. We have a joint venture company, IoT Biogas, Indian Oil Tanking Biogas. So there we have 5 retail outlets we have converted, and they are all connected and selling CBG. So this one, Pune one is municipal solid waste they are converting. Kolhapur one, Spectrum is converting press mud. Namakkal is a press mud chicken litter. All sorts of waste are being converted. Another 2 in Gujarat, Surendranagar and Anand. It has come in the month of August and month of September. These are all cattle dung and vegetable waste. Then coming to Surat, this is the 1st December. This month only we have got Surat. They are on organic waste. Rohtak, Haryana, it has started on 11th December. This is from press mud. And another 2 plants here, Chikka station and Chikara station. So total 13 stations have been already started, and we are giving 2 industrial customers also for from Namakkal, from our this thing. The ones RK still, they are taking CBG and they are using this for their process. Very important bio-manure. There is increase in crop yield by 20%, reduce present consumption of chemical fertilizers by 25%, and you can see the replacement of chemical nitrogen. This is an organic fertilizers, and this Aishadium is our brand from IoT Biogas. It's taken a very wide market and market acceptability, and it is leading to organic farming. And you may be aware that fermented organic manure has been included in the fertilizer control order. So this can be marketed without any hitch now. Another option technology what we are trying, that is from waste to energy. That's through gasification. Now this gasification, which today's your seminar is on gasifications. So we are actively working with a technology provider, which will be handling fresh MSW and also legacy waste, and will convert through the route of syngas, and from the syngas we will be able to start to power generations, hydrogen separation, then chemicals, and also liquid fuels like ethanol. So we have started a demo plant constructions in Delhi. So with this we'll be scaling up once the demo and all those things gets completed. Used cooking oil to biodiesel. This is another area where we are actively working on. You know that every household uses cooking oil, but generally houses cooking oil we don't throw very limited quantity. But in hotels and also the food business operators, there are all this Haldiram, then McDonald's, then all other units and big hotels. They have the restrictions of throwing off used cooking oil after certain use. For your information, after second and third frying, because we are not supposed to use that cooking oil, because it becomes carcinogenic and also it's not good for health. So FSSAI has stipulated 25% total polar compound limitation for this used cooking oil. If it is more than that, then you are not supposed to use that. So that used cooking oil is being collected, aggregated, and used for production of biodiesel. So that is one area we have been given an EOI, expression of interest is already there. We have started in this is 2009 on the 10th August, which was the Biodiesel Biofuel Day. So Honorable Minister has inaugurated this program. So this is also going on parallelly. So far, we have been getting very good responses from state. This is the process of this processing of biodiesel or biodiesel production. It is otherwise on waste, because either this will go to a parallel food chain or it will go and come to your disposal through drains and all those local areas. So that's also, I consider it as a very serious waste, and that can be converted for a value additions and which can produce biodiesel, and up to 7% biodiesel blending in HSD we are carrying out in the country for keeping the diesel. We are a diesel economy, so I always say, so petrol, ethanol is blended in petrol. That is one way we can save petrol. But biodiesel blending in HSD will give a big boost for replacement of the fossil fuel with this type of waste fuel. And this waste oil will ultimately help in getting the reduction in the import for this country. So far 29 LOIs have been awarded, and which will have a cumulative capacity of 637 ton per day production of biodiesel. So this is the flow chart. 200 cities we have identified. Then EOI through AY LOIs are being placed, and OMC are taking 100% offtake at a price guarantee, and we are selling through our marketing network. So this is the model, and FSSI is actively supporting it. Every state we have made a committee, state committee. Now this will also give a boost for them because the collection and aggregation challenge is already there here. So once that logistics is developed, then things will move faster. That is the target what we are trying. Fourth option is cellulosic ethanol, which is, say, second generation ethanol. Here also the biomass, same biomass like paddy straw and other biomasses are being used through pretreatment and hydrolysis, and then fermentations through distillation we can make this cellulosic ethanol. And this also through gasification or through syngas, this is also the same process where ethanol. So we are trying with both the technology. We have our plant at Panipat, which is coming up, which is around 50% of the work has been already completed. We're expecting by end of next year, 2021 end, we are getting this second generation ethanol plant in the country, which will convert paddy straw 700 ton per day, which will be 2.2 lakhs ton per annum. That's paddy straw, which will be converted into ethanol, which is second generation ethanol. Gasification route, as we have said, we are trying this also, and then future we have a plan to convert syngas into ethanol. This is the enzymatic hydrolysis process. This is a schematic diagram, cellulosic feedstock, and then saccharification and co-fermentation, and then we go for a cellulosic ethanol. I'm not going for technology, these things. Pet coke gasification, this is one more area our R&D is very actively working on this. This is R&D center, we have already developed the gasification concept with the employing pyrolysis and low temperature moving bed fluid bed gasification system. So this process is capable of handle various other systems with biomass and its derivatives, lignin, black liquor, which are the major areas which are available, which can be converted and adds lots of value here. And this methodology enables segregation of various feedstock depending upon their reactivity, ash content, and making the process energy efficient. And by processing high ash Indian coal in low temperature first stage, ash rejection takes place at much lower temperature. As people who are from technological background, they can understand this. And this is an area where we are very seriously working because we generate lots of pet coke in our refinery. And we got a patent from US, Europe, and India. And 2 TPD demonstration plant is being set up with our R&D. So overall, what is the intelligent use of waste? So prima facie, waste is not a waste. I always say that there will be time when you have to keep the waste under lock and key because the market will demand waste and it will have superior value. So that will become an asset for you. So there the circular economy concept comes. We have water, we have biomass, we have feedstock. Now we have to ensure quality environment, economic prosperity, and social equity. This is possible with this all bio-route, biogas, bioethanol, biofuel, bioenergy. Looking forward for a green India and with all the waste, which is a challenge for today, which will have a productive use, which will have a self-reliance. Thank you very much. That's all from my side so far. Thank you very much. Thanks, sir.
Thank you so much, Mr. Gupta, for the presentation. Moving forward, before we take questions, we have 3 more presentations. I would like to invite Mr. Shete, and then I would like to invite Mr. Dave and then Mr. Bakshi for their presentations. In the meanwhile, I would request Mr. Gupta to be with us. If we receive any questions, we'll be more than happy to pass it on to you.
Yeah, but otherwise you can take the question because I have a meeting at 12:30 again.
Absolutely,
So
not
I
a
can
problem.
tell me, I will just respond to email also. That's also possible.
Absolutely, not a problem.
Okay, thank you. Thank you.
Thank you. We have our fifth speaker also joined us, Dr. Ira Tiwari.
Hello, Dr. Theory.
Hello, sir.
Thank you for giving this opportunity to Praj to present the experiences and some thoughts.
Just a small request if we can put this into a slideshow mode.
I'm doing that, yes. Okay. All right. So what I would very briefly cover over here is that the classical terminology that we call as organic waste, and organic waste very predominantly means the waste which is produced from carbohydrates, proteins, etc., which are plant origin or animal origin materials and not hydrocarbons. How do we, and we use it for different purposes in our day-to-day life, and then create something which is currently unuseful. How do we valorize this into a, gainfully into bioenergy? So that's the theme. I will very briefly cover a little bit of background about Praj, and then I'll go into the presentation. Praj is almost now 37-year-old company, started in 83. We had our IPO, and we also had market entries, etc. in the 90s. We set up a very big R&D center for bioenergy and also entered into European and American markets. That was in the first decade of new millennium. And we then focused on the non-edible organic waste, non-edible organic sources and the waste to be converted into bioenergy in the form of mainly biofuels. So that's our journey. We are a company of 1,200 people with 90 research scientists. Our business model is we supply technology and plants. We are present across 75 countries. We have various business lines, but of course, bioenergy and the research focus around bioenergy plants is the main theme that we have. The rest comprise the effluent recycling, critical process. We have a global leadership in biofuels, of course, ethanol and renewable gas plants, and we do right from the feed audit studies up to the complete construction of plant, commissioning, and also the project management along with post services. This is our R&D center, which is one of the unique ones dedicated to bioenergy and especially using various waste streams and converting them into useful biofuels. That's the theme behind our R&D. Coming to biofuels, first of all, which we feel is a key to sustainability. If we look at the major challenge today is petrol and diesel. Let's be very specific about it. They are the major contributors to carbon and GHG emissions, causing health challenges across the world. Therefore, every sector, be it vehicle manufacturers, oil companies, everybody wants to go away from it, preferably to much less hazardous alternate renewable sources. And they typically comprise bioethanol, bio-CNG, as Mr. Gupta also spoke extensively, biobutanol, which is a new concept coming up for aviation fuel, SAF, because they are clean burning, renewable. They also give valuable co-products like organic manures. And when it comes to India, they are the key to Atmanirbhar Bharat, promoting circular bioeconomy and as well as having a very good socio-economic impact. So this is the importance of it. Very quickly coming to what is the plan of Ministry of Petroleum and Natural Gas in coordination with Ministry of Agriculture. It's very, very straightforward. Blending 20% bioethanol into petrol by 2030, replace 15 million metric tons of CNG with bio-CNG or CBG by 24. Very well-defined targets and very lucid and clear targets. What it is going to do is going to save almost 10% of our forex oil bill and pumping it back to the wealth into farmers and rural economy. That's I think critical. And on the other hand, what it connects to is also utilizing gainfully and sustainably the organic waste which is produced from agricultural sector like straws, agro-industrial sector like sugar mill, press mulds, distillery spent wash, and the city waste that we all generate through MSW, food waste, etc. If we put all these together and they are gainfully used in a systematic way, I think this target is very, very easily achievable. And that is the key significance of using all this so-called waste. And as Mr. Gupta very rightly said, you have to keep it in few years from now, you have to keep it in lock and key because it's going to be a gold. And we will derive our clean biofuels from this feedstock. Just to summarize, we have 4 types of waste. One is lignocellulosic agri-waste, which comprises rice straw, wheat straw, corn cob, soybean straw, etc. We have industrial waste coming out from, let's say, sugar mills and similar kind of operations. Farm waste, where we have ample cow dung, chicken litter, because this agro-industry is again growing, is a major source of organic waste, solid waste. And then finally the city waste, which is municipal sludge waste or food waste. If we look at agri-residues, which is a major feedstock available, we are literally sitting on the stockpile of it. One can produce bioethanol, and we are doing plants now for IOCL as well as other oil companies to convert rice straw into ethanol. Bioethanol can go as transport fuel. We are also developing now the technology to produce biobutanol, and certain trials are now conducted along with Institute of Petroleum Dehradun and other agencies, that it can be used as aviation fuel, sustainable aviation fuel. One can produce compressed biogas, and that's where we are again working on the technology and plants to utilize gainfully this rice straw and convert it into compressed biogas. Whereas when we look at the other industrial organic solid waste, industrial or farm waste, they all can be converted into compressed biogas with very, very advanced technologies now. And this is going to form the core of our transport fuel as well as power and heat requirements. Government and MOPNG have taken a very, very planned and serious effort, very accelerated effort towards this, and we are working with them. So when we very quickly look at agri-residues, they are quite abundant, almost to the tune of, I would say, 150 to 200 million metric tons. And these are some of the types. They are cellulosic in nature, and they need some kind of a pre-treatment to extract the sugars. They can be made available around the year because luckily India has a very good combination of 3 seasons for plantations. So all the time from our farms, this resource keeps on coming as available resource to convert it into energy. When we look at typically their composition, rice straw, a metric ton of rice straw has a potential to give almost 400 cubic meters of gas. And as you can see, most of the other materials are in the similar range. This translates into about 150 kilograms of compressed biogas per metric ton, and which is a very attractive and viable conversion. What it means is half of the organic matter contained in these natural resources very efficiently gets converted into clean burning renewable bioenergy like biomethane. And that's the significance of it. Because there are certain technical challenges, and Praj as well as IOCL, R&D, everybody is working very strongly to resolve them. There are processes which we have developed which use enzymes or microbes to extract very efficiently the organic volatile solids and convert them into. Very quickly looking at the two technologies or for two vital biofuels, biogas, compressed biogas and bioethanol technology from various organic wastes. Waste to CBG plants, we have developed a innovative microbial technology which solves the first challenge of lignocellulosic hydrolysis. And as you can see pictorially represented here, a simple microbial pretreatment will dissolve the lignin and take away the cellulose and hemicellulose from this waste and make it available for biomethane bacteria to produce. The second challenge is how do we convert now these volatile solids into biomethane? And this is where we have very actively worked on rumen culture from cow stomach, where they are able to degrade fiber and produce methane, and that today is available as a commercial solution through our plants. And these two combined together can give a high yield of biomethane from this waste. Third important point is the critical value-adding manure, which is in the form of both solid manure and liquid manure. Now, this has been also notified in the fertilizer control order by Ministry of Agriculture, and it is a very gainful manure replacing use of chemical fertilizers. We also have this NOCA certification available. Coming to the technology of making efficient biogas, we have collaborated with a US-based company called DVO, and they have a plug flow design system buried under the ground or soil, which works without any stoppage or any maintenance for decades together because of its construction and robustness. We are installing currently 2 plants who would supply the biogas or compressed CBG to IOCL. One is coming up in Uttar Pradesh, the other one is coming up in Karnataka, and we are going to do multiple such plants which will be using the organic waste. The manures, of course, as you can see, they are well approved both in Europe as well as in US, and these are improving the yields and also the humus, making the farming soils rich and do not allow them to go alkaline and go out of farming cycles. Biogas needs to be upgraded to CBG, and we also have commercial solutions there, either membrane systems to remove the carbon dioxide or water-based systems, as well as removing the sulfur. So the desired quality of CBG expected by the oil companies, we can guarantee having methane above 90% and the other impurities well within the limit. Typically, when we look at using rice straw as one of the organic wastes, if we use 100 tons, it will give almost 15 tons of waste biogas every day, around 35 to 40 metric tons of high quality organic manure as a co-product, and about 125 cubic meter of fertigation, which can go to the farms nearby. So this is one technology of compressed biogas which can utilize a variety of organic solid waste. Coming to the other biofuel, which is bioethanol, Praj has also done considerable work on rice straw as well as other feedstocks to make bioethanol. This technology is called Infinity, and we are installing plants, commercial plants now. This is a typical block diagram through which the biomass is processed through the cleaning, size reduction, pre-treatment, hydrolysis, fermentation, and then recovery of ethanol. Also, the lignosulfonates can go to the boiler or to the bitumen, and by evaporation, we can produce additional. Typically, corn cob, same feedstocks like CBG can also be used to produce ethanol, and they differ depending on the cellulosic contents. The yield of ethanol can vary. So this is a processing plant in terms of steps: feedstock handling, preparation, pre-treatment, enzyme hydrolysis, fermentation, product separation, and the waste treatment. By using biofuels and producing them through the organic waste is critical. These are the key points we would like to say. A 20% ethanol blend and 15 million metric tons CBG production from all these vital gold waste, I would like to call it really gold, can save our country almost 80,000 crores of foreign exchange, which is roughly 10% of our crude oil import bill. Sounds very dramatic, but it is not. If we all work towards this goal along with the ministry, I'm sure in the next 5 to 7 years, this is achievable. Now, where does this wealth go? It goes into the circular bioeconomy. It goes to the agro-industrial farming economy and helps rural skill and job creation, improving farmer income, reducing pollution, as well as making us Atmanirbhar through these routes. And at the same time, the commitment we have as a nation to the Paris Climate Summit, we will definitely be reaching towards that. So it is achieving multiple objectives gainfully from properly processing the organic solid waste coming from farms, from cities, and from agro-industry. If this network is properly established, I think there is considerable benefit, economic and social benefit out of this. So these are some thoughts on behalf of Praj I wanted to share with you. Thank you so much.
Thank you, Mr. Shete, for the presentation. And we do have received few questions, but we are going to wait for it. We will be taking all the questions after the presentations. So I would request if you will wait, then we'll be more than happy to share. Otherwise, we'll be sharing the same over the mail to you.
Please do that, because I have another webinar with a group of bankers, so I will have to leave. But I will be always available on my mail. I'll be very happy to interact with all of you, and thank you for this opportunity.
Thank you. Thank you so much, Mr. Shete. Moving on, we have three wonderful speakers left, and just to tell that the three speakers that we have on board, one is an innovator, one is an experienced solution provider who understands the technology, and one is the person who understands research. So moving on, I would request Mr. Dave to start the presentation, and then I would request Mr. Baxi and Dr. Tiwari to follow along. Over to you, Mr. Dave.
Yeah. Can you now see my screen?
Absolutely.
Okay. First of all, thank you very much to the audience and also the organizers for giving an opportunity to present what Abellon is all about into the waste energy space. What you can see is one of the project which is coming up in Ahmedabad as one of the model project as a waste to energy project. I will just like to talk about something more in detail about an Abellon and the project on which we are doing. If we just talk about a little overview of Abellon Group, we are very happy to say that we are a pioneer in the waste to energy space in India. We have been instrumental and working very closely with the policy makers and the government for defining and designing the waste to energy rules and the policies. We have a very strong proven track record and unique R&D technology and development skills at our end. Predominantly, we talk about the businesses which are, having a triple bottom line approach. That means which has an environmental protection technologies, which also has an economic progress in the way and a social development. So most of our initiatives which are currently we are strong into have all these things in a very as a very strong USP. We have 3 business lines as a renewable power. It means that is a bio MSW. We have a dedicated municipal solid waste plant with a city waste plant, solar power generations, and combined heat and power models and the projects. Another business line is a renewable heat, in which the solid biofuels and the equipment used for the cooking and industries and in agri-science. So if you see, there are business energy. We have solar energy projects together with the very innovative projects of government of Gujarat connected with the farmers. Also waste to energy projects in 2 models, as I said, one with a dedicated city waste to municipal solid waste projects, and others are the biomass powers together with the RDF co-firing, and we can use any source of a biomass as a power source. Together with this, we have a biomass renewable heat projects. That means a biomass pellet projects, 2 projects in Gujarat, 2 more projects are coming up in other parts of the country. And to use that biomass pellet in a right way, we have a pellet-based applications and the appliances. You can see that a very large spectrum that is in the development verticals, because it is supported by our strong R&D team. It is a biomass characterization, biomass collection systems that is very predominantly very critical into the biomass projects, and energy farming, because as we said that these were the previous slides before I spoke to you. It's a waste to energy project at Ahmedabad. This is the Abellon group, which I talked about previously. And these are the self-sustaining and evolving business models on which the Abellon is working. There are, as I said, 2 business verticals of a renewable power and renewable heat, and there are 3 R&D verticals. This is very strong in biomass resources. One spectrum is a technology development, and another is a renewable fuel uses. These are certain key milestones in the journey so far. We have been working very strongly into the biomass spectrum since 2006, 2008, 11, 12, all these successful milestones, as you can see. And these are first certain awards that we have been received. One of the important award that we have received is the Zaire Future Energy Prize in 2014, which is considered as an Oscar in energy area. Ashden Award 2011, that has been awarded directly by Prince Charles to us. There are few areas in which we have worked in African Business Awards in 2015 because of our project in Ghana and various others. Same way, we are working very strongly into the waste to energy and biomass subject. As you can see, as a R&D is our DNA, because as a primarily our group belonged to the pharmaceutical industry in the beginning. So R&D is something which we are very strong into. We have more than 20 today, right now, almost more than 28 patents. We have various international publications working in global collaborations with USA and Germany and other part of the world with the universities for their collaborative research projects. We also have several funding agencies, those who are working primarily into the fundamental research of the biomass in a value chain in a chemical and liquid fluids and liquid fuels. So we are connected with, and we work very strongly in a collaborative nature with various other projects across the world with universities and organizations, those who work into biomass area. Having said that, if we talk about a waste to energy project, we talk about what we did in Ahmedabad. So if we consider Ahmedabad as of now as around, very recently the boundaries of corporation have been increased. So few more areas have been included inside, and it's around more than 4,000 tons of a day, more than 12,000 street sweepers, 1100 collection points, and I'm proudly saying that Ahmedabad is one of the very few early starter to cover 100% of the waste collection into the dry and wet waste. More than 1,000 vehicles are there, which is collecting the waste, and they are collecting and they are transferring to the 6. Now it has become 7 transfer stations. So it is from a door or a gate to the dump project, and they are container and lifting operations, and they are segregated and collected at those stations. They also have a separate collection systems for the hotel and the kitchenware waste. So it's a wet waste is collected separately. So as I said, so this waste is being transferred from door to door and other places to transfer stations where this is where it is being segregated, and also there is a separate arrangement to collect the wet waste from the hotel and the kitchen waste, and from there it is being transferred to the specific land which has been earmarked. Out of that, this RDF and this waste is being diverted. Out of this, 1,000 ton per day waste is being given to us to produce an electricity. So this is an arrangement that we have got with Ahmedabad Municipal Corporation. So we, run through the various due diligence processes, and it was basically trying to understand very deeply how the waste it is. The waste will be different from a different part of the cities. As you understand that every city has got a different socio-economic profile. And depending upon that profiling and urbanization, the waste will be different. Same way the collection method and the transportation is different. The composition of the waste, it has to be understood very deeply. At the same time, once the waste is understood, we also have to understand what the technology it is there and how it is relevant to the local waste. How, and considering that, what is the global precedence and the references available? What are the technology partners available? And the operation and maintenance requirements, scalability, very important, the environmental controls and the compliances. So we did all these due diligences together, and then finally we decided what the appropriate technology it is, what the key technology partner can be, what can be the scope, and what can be the balance of the plant and the partner type can be. Having understood this, we tried to understand the waste very deeply. So we have done a sampling of more than 150 trucks, more than 34 tons of the trucks samples were being selected. Out of that, we derived more than 1,400 plus samples to conduct an R&D onto it, spent more than 2,000 hours and covered almost 6 zones. And type of the waste we studied was fresh municipal solid waste as well as the legacy waste, which is already there as a dump site, and also with a residential and commercial. So to understand the entire spectrum and type of the waste, we did all this waste characterization in our learning process. So this is how it was done. Various types of the waste when it comes in from the various places. From various places, then the mixing is done, then the representative waste sample was derived out of it, and then segregation process, and then what type of waste actually it composed of. So that was a pure R&D we did for more than 1,400 different samples. We also studied the samples across the time right from 2010 and various compositions in terms of the metal, food, plastic or whatever it is, and what percentage it is. There are also 4 different type of the analysis in terms of parameters, that what is the physical composition, what can be the moisture composition, how much ash is there, and finally what is the calorific value. Because this calorific value is of an utmost importance for every one of us, because the project is basically to convert that calorific value into the usable energy. So across the spectrum, various type of the material, various database we created and ran through various database analysis to understand this waste. So there's a mammoth task we undertook before we started this project. This is how it is being transferred. As I said, Ahmedabad fortunately has got a very early mover advantage with having the transfer station infrastructure in place because by the municipal corporations. So this is how at different places the waste is collected from door to door and to the stations, and from there it is being delivered at our doorstep of the waste to energy project. Very important part was emission norms due diligence, because we all understand that all the projects across India have hit this particular subject very hard way. So we studied that there are MSW rules 2000 and 2016, that was the latest rule, and what are the European norms. So our project is going to comply that European norms, which are, you can see that even the stricter in some areas, and in some places it is equivalent to even dioxin and furans, it is equivalent to European norms, our norms. But same time we have tried to implement a technology which can comply with the European norms or the EU 2000 emission norms. We also studied the plant and vendors at various places across the world, more than 35 visits, 35 places. The teams were sent to different places to understand the technology and the waste and understand. The technology which we finalized was an incineration technology, which is proven globally. More than 1,000 plants are there across the world, and the technology partner we selected was a Keppel Shager, who is from Europe, who is a multi-billion-dollar group in Singapore, and set up more than 100 waste to energy projects in 25 countries with different ranges of a capacity of 500 tons to 3,000 tons in a capacity range. So we understand that the group who can help us and be with us in an entire journey of our growth and setting up various plants at various places. They already have, as I said, set up plants at various places in the world, and this is a type of a technology which So what we did is a complete plant. The EPC is done by our own group. We have our own strong team of EPC who can work on a technology which is being supplied by a technology partner. So we worked on as-is mixed waste with a high moisture, low energy value, and the emission control being also taken care of correctly. To do that, this is a typical, plant design. I will try to see if I can run this. An animation. Can you see the animation which is there?
No, animation can't.
Okay, fine. Okay. So this is a plant wherein there is a waste which will come from the corporation directly being unloaded here. It is a human intervention free plant wherein no human intervention is required for handling of a waste. It is set into the waste bunker. Here the bunker will store the waste for almost 3 days. More than 3,000 tons of a waste can be stored over here. Then we have a furnace and then thermal heat recovery system which will produce the steam which will go to the steam turbine, and the flue gases will run through the advanced control emission systems and which will go through, pass through this before it going to the chimney. As you can see, the technology suitability was studied very deeply, and you can see that there is a type of a grate that has been designed. That means, the major problem with the MSW plant is that the quality of the waste is never in our control. We have to accept whatever is being received. We have to use whatever has been received, and we have to have a technology adjustment done to use this waste to produce the power. So here in this entire grate, once this waste is charged from this place, it is passing through the 40-minute cycle, and it is being tumbled, and it is being slides for almost 10 times before it gets out of this furnace. So we have 100% control over the material. All the particular places into this grate has got an automatic robotic systems. It has got an intelligent artificial intelligence systems to understand and to see how much temperature is there, and also it is able to control the temperature at the various part of the grate with reference to the type of the waste which is there inside in the process. Then this boiler thereafter is also designed in-house together with a technology supplier, and then this this flue gases will go through this rotary atomizer of emission control systems. So once we do a due diligence for an emission control systems, you can see that there is once the contaminated flue gas will pass through this lime milk slurry system, which then through an activated carbon system, and then this particular waste is being, the emission, once it has been captured, which will be captured into the fly ash in a residual, and then the clean gas will go through the ID fan to the stack. Now, thereafter, we did not get satisfied. We also got into a further planning, and that is, we tried to cover that we can capture the carbon dioxide also. So now, after this new initiatives by Government of India under the Ministry of Petroleum and Natural Gas and Honorable Minister, we have got a very strong interest into carbon capture and utilization and storage technologies. So we tried to implement this. And so now what is proposed over here? So what we are going to propose is that we are proposing a carbon capture and storage unit before this flue gas is going out of the stack. So, and then we have to see that where the CO2, the captured carbon can be utilized. Fortunately, by grace of God and, the kind of advantageous location of Ahmedabad, we realized that there is a possibility of usage of the carbon dioxide by an ONGC to use that in EUR application. So this is how it is being used. So Abellon becomes a waste to energy plus carbon capture plus enhanced oil recovery and carbon sequestration project. That is a first of its kind project in India. That means from this project, after using the municipal solid waste for a carbon generation, for a power generation, whatever the flue gas is going out, we are capturing the carbon dioxide over here, and that carbon dioxide will be utilized by ONGC for a storage beneath the earth for an enhanced oil recovery. How it is being done? This is a typical system wherein once the carbon is separated, it is injected in a wellhead into the ONGC oil fields, which will help to enhance the oil recoveries from a depleted or aging oil wells, which is producing the oil today. It helps two ways. One, it will capture the carbon and sequester underneath. At the same time, it will help the oil producers to get more oil and from the aging and depleting oil fields. Fortunately, we are very close to the oil fields of an ONGC. So we got a tie-up and we are getting into a further understanding. So the general advantage, the benefits of this waste to energy plus CCU as project is a clean electricity production because it's a minimal carbon footprint. It has enhanced oil recovery because the oil related royalty will be increased. At the same time, our oil dependency from an import will be reduced substantially. It will also be a permanent storage of a CO2 in an oil well. This technology is very well proven. It is being used by all the countries outside India very significantly since many years. So it is a mature and proven technology. ONGC is looking at a possibility to use it, and we have come as a partner to them. At the same time, it becomes a waste management and sustainable development. And this is the first project of its kind in India as a template for a future similar projects which may come up in India and Gujarat. At the same time, it can also help, compliance of another sustainability development goals for our partner because it is an affordable and clean energy. It is an industry and innovation infrastructure project. It also helps a sustainable city and communities, and obviously, it will achieve a climate action goal. So this is a 15 megawatt project which will be able to capture 100,000 CO2 per year. There's a 1 lakh tons of a carbon dioxide per year. It's a significant number, and this CO2 will be utilized by an ONGC field nearby Kalol, which is around 35 kilometers from this place. So it's a very, we are proud of such type of project to get associated with ONGC. We are also in talks with other projects which are coming up in other places in Gujarat, like Baroda and Rajkot, and the things are under consideration. So this is a salient feature. If you see, it is 100% soil conservation. We have taken care of the project from the beginning at the time of the conceptualization, that even the 1 kg of the soil we have not taken out, and 1 kg of the soil we have not used outside the boundary. We have also taken care of a rainwater harvesting and recharging. The water which is being used is the city leftover water instead of the fresh surface groundwater. That is a very typical and probably the first of its kind project being worked out in India. That means the water being used, it is a city leftover out of the STP, that is sewage treatment water plant. In the campus, we have created the lush green environment and dense tree coverage to more than 10,000 trees have been planted, and when we got the land, it was a plain barren land, and today you can see more than 10,000 trees are there. So it is and we are trying to bring it to a zero order, zero pathogen, and minimal or no human intervention into the entire lead activity. So it is a salient feature. We are creating this campus as not only a waste to energy plant, but we are creating a waste to energy campus that is envisaged an integral part of all activities and the life of the community within which the plant is located. So we are going to invite the visitors from a different section of the societies to see and understand and take their art and photography. We have kept various areas there available for the people to come and enjoy and make as a picnic or a kind of a visiting place. There are also guidance and support to promote a green initiatives within the campus and surrounding area. So, there are dedicated nurseries, maintaining inventory for native tree saplings, giving to and inviting the people from a nearby and other places. There is also a space for a display and trial of a green and clean tech products, solutions like even maybe electrical vehicles, even the solar system. Within the plant itself, we have got a solar tunnel in which the solar plant is also implemented. Various visuals, art exhibitions, the music, the dance trials, recitals, celebration, festivals, and all that we are going to create. All the outdoor sports activities such as football, cricket, volleyball, that is also being organized. This being ground, we are going to give this ground as a use as a free to the municipal corporation schools, those who are not having enough space for their the sports activities, and also the lighting based elements and various attracting activities that we are going to keep over there, so that it becomes an experience rather than just a visit to a stand. I am proudly saying that we were the first recipient of such award. The contract of setting up such projects, but we never knew it will be a very difficult story to start, because we had to work out various interventions at the policy level to make this project successful. You can see this is a footprint of a project under construction. You can come and see and visit. We welcome anyone and everyone from an industry or from a society to come and see. This is a sample project coming up at Ahmedabad, which has received IGBC Platinum Certificate Good Watts WT Ahmedabad project, wherein you can see that there is a plant and you can see that there is also a ground here. This is a water channel. This water is rainwater harvesting. At the same time, this water is being used from this inlet of this water is from a city's sewage treatment plant, so it is leftover water. There is an amphitheater here. There is a drama and kind of a program, display projects. There is a solar tunnel that you can see over here, and there is a ground. And at the back of it, there is a project. Whatever you can see over here is a glass tunnel, the glass window through which a lighting is done, and 24/7, 365, anyone can see and watch an activity of the project from even a distance. The same way, this project is a Jamnagar project. The Jamnagar project also has won the IGBC Platinum certificate. Here you can see it is a biogas project that also is coming up. We have partnered with IOC for the same. The same way, here's a ground, more than 10,000 trays, lush greenery is already existing as of now. There's a solar project here, and the project is also the visible from the overseas, outside of the project, the activity of the plant. So the concept is same. This is IGBC Platinum Certificate, one award Rajkot. The same way, so the concept is the same. So we are creating not only a waste to energy project, but we are creating a waste to energy and a renewable energy campus, which can be a real milestone and a landmark project for everyone to come and see and visit. Again, it is a 15 megawatt, 1,000 ton of a municipal solid waste processing project. Thank you so much.
Thank you, Mr. Dave, for sharing your thoughts and your initiatives that Abellon is taking and moving forward with the government in Gujarat and other parts of India. And thank you so much for your presentation. We have received few questions, but we'll be taking this after the remaining sessions from Mr. Baxi and Dr. Tiwari. So moving on, I would request Mr. Baxi to continue with the last presentation from Intelligent Waste Management, and then we move to Dr. Tiwari, who will be presenting on the technology, the development and technology of W2E in India. So over to you, Mr. Baxi, and kind request to keep the presentation crisp for 20 minutes so that we can have both the speakers in the allocated time. Thank you so much.
Good afternoon, and thank you very much. Just want to know whether you can hear me.
Absolutely.
Okay, wonderful. So let me quickly share my screen. So good afternoon, everybody, and thank you very much for joining this session. The advantage and disadvantage of coming fourth in the line is that there are a lot of points which are already talked about, but one probably gets a chance to go into the details of a few. I'm going to talk about agro waste management and the type of intelligence that one can build for the purpose of efficient energy generation. My name is Suhas Baxi, and I'm co-founder of a company called Biofuel Circle, which is a startup setting up e-marketplace for bioenergy. I think agro-residue-based energy and the circular economy associated with it is something which everybody has talked about so far. This is an economy which uniquely connects the rural and the industrial landscapes around the world. You've got a farmer who is essentially generating agro waste, rural businesses who are aggregating the agro waste, processing it, supplying it to bioenergy companies, and later on the produce of bioenergy companies is being used either by industries or by the farms themselves. So in more than one ways, this economy is a true circular economy, carbon neutral economy, and one wanted to look at what can technology intervention do to the supply chain of this industry. So we started investigating how does the supply chain of this industry work, and quickly realized that the supply chain is very complex. On one hand, you've got whole lot of participants from the rural side. The agro waste is essentially a seasonally available produce. So whenever it is available, it's collected from various farms scattered around the country and brought to storages for just storing or for processing. Now, the reason why it is important to understand complexity here is through the two words seasonal and storage. Seasonality essentially reduces the number of days in a year for which it is available, and storages add to the cost of infrastructure as well as cost of financing the storages. This in turn is used in process industries like sugar mills, rice mills, etc. And it's also used in energy companies like power plants which are using briquettes, or process boilers which are using briquettes for burning in their furnaces. CBG plants, ethanol plants, biodiesel plants, they happen to be customers. What's extremely important from a supply chain point of view to understand here is that the crop which is generated on a seasonal basis is required on a daily basis. So the complexity of organizing daily transport, scheduling it, making sure that industrial production is not impacted due to unavailability of the biomass at any point in time is a critical challenge for efficient working and also viability of some of the bioenergy plants. What we have seen is that a large number of projects do see viability gap on account of the fact that they can't run 365 days in a year or even 300 days in a year. So one important problem to solve in this supply chain is to make it reliable and to make it available daily for 365 days in a year for industrial consumption. While this seems to be what I would call as a relatively matured part of the bioenergy supply chain, the developing part of bioenergy supply chain is essentially around the produce of the bioenergy plants, which could either be compressed biogas or ethanol.
Mr. Baxi, we are not able to hear you properly.
I think the last point where I probably could not be heard is the evolving part of the supply chain. And this evolving part of the supply chain is essentially coming out of the new bioproducts like bioethanol and biogas, and setting up a reliable supply chain for these products to supply to the industry as well as automobile applications is another challenge that one sees here. The next bit of challenge, which is very interesting, is once again coming out of the so-called biomanure or biofertilizer, which could either be supplied back to fertilizer plants or in a truly circular manner, getting it back to the farmers. Now, I think the reason I kind of took you through the paces of this supply chain is to look at how many different type of transactions are involved, how many different type of dispatches are involved, how many different type of vehicles come into picture, and how many different participants are there in this supply chain. Now, if this supply chain has to be run for the potential that everybody is talking about, then it's extremely important to understand what are the problems of this supply chain. And we did a little bit of investigation to find out what are the problems of this supply chain, which seems to be relatively underdeveloped. The first problem is reach. It is very difficult to reach logistically every small farm in India and to actually aggregate the agri-residue which is available. For biodiesel companies and biogas companies, reaching to their own markets, not only their suppliers but to their customers, is also an interesting challenge to look at. Of course, seasonality is a problem which results in high cost of storages and interruptions in supply chain as far as biomass is concerned. Price discovery is relatively underdeveloped. On one hand, the farmers do not really get big economic value out of biomass. On the other hand, the industry does pay a price which is at par with what international prices would be. And last but not the least, the supply chain and the complexity of the supply chain does not allow companies to scale up. I mean, we saw the Abellon presentation a couple of minutes back, and it's a humongous effort to actually make these 8 or 9 plants work. If they want to scale up, it's extremely important to understand what kind of role digital technology can play in making this supply chain more sophisticated. And that's where one started looking at, and I'm going to skip this slide because this has been covered by, the various other speakers from IOCL as well as, speakers who spoke before me. But when one started looking at digital transformation of this supply chain, we looked at digitization and digitalization both. What can be done to reduce the cost in this supply chain? Okay, how do you help reduce the cost? Maybe infuse technology which will allow you to convert from paper to non-paper and stuff like that. But these are small impact projects. How do you digitalize this supply chain so that the customers and the companies, their suppliers and the companies,
Okay.
How do you?
Actually, yesterday also I tried. I could not get that option.
Hello, can you hear me?
Okay, awesome.
Okay, so I assume you can hear me. So digitalization essentially needs to be around how do you change the way of doing business, and how do you help companies in this supply chain look at revenue streams which are very different from what the current revenue streams are? How do you help companies look at business models which are very different from the current business models? And that is what we decided to work on. What we are in the process of doing is to create, and I'm once again going to skip this slide and come to a slide on biofuel circle as a platform. What we are in the process of doing, ladies and gentlemen, is we are connecting farmers to rural businesses and farmers and rural businesses to bioenergy companies, and all of them in turn to industrial participants and back. We are bringing banks into the ecosystem, and we are bringing transport services into the ecosystem, and thus create a marketplace which would allow the participants to seamlessly buy, sell, transport, settle, and even get financing for the trade which they are indulging into with each other. In the process, address some of the basic constraints in evolution and scaling up of this industry. Can the farmer get the right price for what he has? Can he transport without making too much of effort out of his fields when he wants to transfer? Can we make sure that there are viable options available for the farmers not to burn the crop, not to burn the stubble? Can we create rural businesses which have an ability to interact with farmers on one side and with bioenergy companies on the other side? Can we create an ecosystem where these rural businesses prosper? What type of rural businesses can these be? A lot of these are issues that we try to address, and we are now in the process of creating the final phases of the platform and launching this platform around January in Pune. We already have one of the larger bioenergy companies in India as one of our alpha customers. We would be getting these players and their supply chains onto the platform, creating choices available, easing transactions, making digital payments possible, and also making financing easy for participants in this supply chain. With that, what we would be in a position to essentially create is impact in areas where you create awareness and visibility around bioenergy. You promote rural infrastructure to harness the biomass and bring it to the industries. Last but not the least, create a trading platform which will allow organizations, small and big, individuals in rural areas as well as urban areas, to participate in this market in a truly democratic mode for price discovery, for transport, for digital settlement, and for financing of trades associated with biomass and biofuel. I know that there is a time restraint here, and I'm sure that this will probably a technology infusion like this will probably create at least some ideas in the minds of companies who are currently participating in this supply chain, and use the technology for the purpose of achieving what could be not only bioenergy transformation but also digital transformation for this supply chain. If we are able to do that, I think what we will essentially be able to foster is an ecosystem which creates more local jobs around bioenergy, focuses on rural economy, create a scale for green energy, which is extremely important, and of course, work on providing energy security to the nation. For the participants in the supply chain, what Biofuel Circle as a platform would be in a position to do is to provide advisory on what, when, and with whom. Provide the visibility for opportunities available to everybody in the supply chain. Create low-cost transport alternatives, because transportation in most cases ends up being between 20 to 30% of the landed cost of biomass for energy companies. Allow price discovery, which is a truly transparent price discovery as far as biomass is concerned. Enable digital payments for all participants in the supply chain. Provide ease of logistics and storage. More than anything else, supply chain financing at reasonable cost, bringing in financial partners on the platform who would be in a position to finance transactions which are true and visible transactions in a transparent manner, and does help achieve growth for green energy in the country. That's what we are about to start. We would be launching our platform in January, as I said, and making our own small contribution into making bioenergy more feasible and more viable in the country. Thank you very much.
Thank you, Mr. Baxi, for bringing in innovation and talking about the intelligent agro waste management. And we are really keen to know and about biofuel circle and the new concepts and the new innovation that you're bringing in. I've requested you to stop your screen sharing so that, and we really thank you for the last presentation for this headliner. We would like to invite Dr. Ila Tiwari, and post that we'll be taking questions. And we request Dr. Tiwari to please do your screen sharing and keep your presentation crisp so that we can take all the questions that we have received for the speakers.
Right. Thanks, Akshay. In this, I will be sharing some information on the technologies which are available in India for waste to energy, the opportunities and the challenges which are associated with the existing technologies, some already executed waste to energy projects in India, and the MNRE scheme for central financial assistance for the execution and the setting up of these projects. As we all know, what is the need for converting waste to energy? It is a potential alternative as well as a renewable source of energy, which has the potential to partly meet the energy demand. And most importantly, it is very useful for effective municipal solid waste management. And yes, of course, it is a viable and sustainable option too, subject to the selection of the technology. The current waste to energy technological options which are available for the effective energy recovery are incineration, pyrolysis, gasification, and landfilling with gas recovery. In fact, now the biomining of the legacy dump site waste is also being explored as a WTE projects. I'm audible? I'm audible, Akshay? Am I audible?
Yes, Dr. Tiwari, please continue, please.
Okay. Yeah. So moving to the basics, waste and its characteristic, I'm focusing here on the solid waste, that is fresh MSW waste, the dump site waste, and including the hazardous, non-hazardous, and other solid waste. So this is a typical MSW characteristics in the Indian cities. The range varies a lot. It's a wide range against all the parameters, the compostable fraction of the waste, the recyclable, including plastic, papers, metals, and glasses, the inert and the construction and demolition fraction of the waste, CN ratio, moisture, and the calorific value. These are the determinant parameters for the energy recovery. So it varies because I have considered the average composition.
She seems to have a connectivity problem.
Yes, looks like. So, in the meanwhile, till we hear anything from her, we will take questions. So, requesting all the attendees to please pose the questions that you have for Mr. Dave and Mr. Baxi. And Mr. Dave, we have a question for you from Mr. Anish Vaishnav, Director for Gangotri Energy. That what is the average CV of the waste fed into at the waste to energy plant, and what is the efficiency of the overall plant, I'll go one by one. We have 4 questions from Mr. Vaishnav.
Okay.
First is, what is the average CV of the waste fed into the WTE plant?
Yeah, nice to hear from Mr. Vaishnav, and glad to reply your questions too. Average CV is actually not in our control, but we have designed a plant with more than 1500 kilocalories per kg as a benchmark, and above it, it is always beneficial for us. The next question, I can read this over here, Akshay. I will just take it. Then what is the efficiency? This is basically is a steam cycle. So it will follow the same Rankine cycle efficiency, whatever it is. And we have an input material and a steam as an output. Primarily, normally, also, power plants are designed with reference to the power as an output. But this will be normally designed as the municipal solid waste processing as a primary consideration, and whatever we get is not controlled. It is controlled through the material that we get inside. So that's how this plant is. And as I said in the beginning, in the debate with Mr. Suhas Baxi for a while, that we are being always considered as a power plant rather than the municipal solid waste processor. So the better thing is, normally you have to look at how much quantity that we process. This is what we are complied with as a municipal corporation commitment, and then as a result what we get is a power. The third question I understand is what is a power tariff? The power tariff is as designed by CERC guideline. It is already there in a public domain. 7 rupees, that's a kind of a benchmark that's in a different way, 7 and 7.8 with a different systems with an RDF and mass burn. So we follow that CERC guideline, and that is what it is. And same way, the average cost per megawatt is also primarily given as a CERC benchmark and a guideline. It's close to 15 to 17 crores per megawatt. That's normal guideline. Depends upon type of the pre-processing and a kind of the other systems that we put into the plant as a project. I hope I replied the questions of Mr. Vaishnav, what he is looking at.
Absolutely. I hope you have answered Mr. Vaishnav's question. We have received a question from Mr. Bakshi from Aditya Sharma, Senior Vice President, Boson Energy. What is the future of waste to energy, waste to hydrogen in India?
Well, I think a lot of these technologies are at a stage which are pre-commercialization stage. And for almost every new technology, the leap from successfully proving technology to commercializing the technology and making people adopt that is a very strong leap. It takes time. I have been a part of some of the hydrogen fuel cell projects in the past in the late 1990s. And you see right now some level of commercial applications for these technologies gaining ground. So the leap from R&D scenario to commercial technology scenario is I wouldn't say long, but it's a process which has to be driven by both technology as well as market acceptance. So I think that is where this is right now.
Absolutely. And we have these questions for both the speakers. We would request all the attendees. I would request all the attendees to, if they have any question, please raise hand, which is an icon drop in their near their emoticon button. They can press raise hand, and we will invite them on stage, or they can write their questions in the feed. And if there are no questions, we would be more than grateful to thank our esteemed speakers. We have one more question. We have one question for Mr. Dave. Do you have technology for RDF treatment to convert to power?
This is exactly what we have the project in place. And the Jamnagar project primarily is using RDF as a feedstock, and output is a power. So we are basically a project developer. We are not selling the technology, and we are actually, optimizing the available technologies for Indian, and the local conditions with the local type of the waste and local requirements. Yeah, thank you.
Sure, sure. So, thank you so much, Mr. Dave and Mr. Bakshi. These are the questions that we have received, and we request all the attendees, if you have any more questions, please feel free to write us, and we'll be compiling the question, and we'll share the same with Mr. Dave, Mr. Bakshi, and other two speakers. And we have one person. We have Mr. Bhaskar Bhattacharya, Chief Manager. I'm inviting him on stage to ask the question.
I have a question that there are a lot of municipal waste depositing in our area. So how can we actually regularly they are collecting the waste and they are dumping there, and that are not giving any foul smell or like that. That is very systematically dumped there. But actually, after hearing all these discussions, I feel excited that whether can we make some small endeavor for rehandling this. Not it can't be. I don't think that what Abellon is a big company. They are managing huge amount of waste. So much amount of waste is not there. So for cleaning the city and for keeping it green, can we manage it by setting small plant, or like what will be the flow chart layout? Can we get guidance in this regard? I'm actually want to know from Mr. Dave actually.
Yeah.
What is your suggestion?
Yeah. Thank you, Mr. Bhaskar, for raising a very important question, because what we have done so far is for larger cities, right? And the larger cities have a larger volumes, and the solution is different. But at the same time, for the smaller cities have their own problems. I don't know how much quantity we are talking about, which location you have in mind, or what is the current situation. I am not aware of it, but we also tried to work on a different model that is called aggregator model. That means we have a Jamnagar plant which is not only working for Jamnagar, but also for the places nearby Jamnagar. That means there are small processing centers located and settled at those places, and then the RDF is being transported from one place to other, and then it is being used in the same plant. So along with Jamnagar, we have 3-4 places. A place you might be knowing called Dwarka, and other small places that are also being catered for. So they are called a cluster-based approach. So at some places, I don't know, but this can work if the clusters can come into existence. That's one.
25 to 30 dumpers usually dump.
It is a too small quantity to talk about for such type of the projects. Actually, it has to be done a very, very different way, and there are different technologies for the smaller capacity of smaller quantities of the waste. So, and as I said, even within the city, also from area to area, the quality of the waste will be different. So, from a rural area, the quality of the waste will be different. The consistency will have to be adjusted, and it is a big challenge. So you are right, but for such a small quantity, there are problems, and there are no short solutions.
If after collecting data from the municipality about the waste content and the nature of the waste, if I can supply those waste, can you provide some at least some suggestion how we can proceed? We may take your help also.
Yeah, we can, but at the same time, for the small, even with the government, Ministry of Urban Development advisors also will be very, very, keen to work on such type of an arrangements. It just we can definitely, can guide it, but I do not know whether it will help your problem. That's my, question. So I'm not very sure whether our guidance will help you because of the kind of the quantity of the waste that you are currently looking at.
Okay.
Thank you.
Thank you.
Thank you, Mr. Bhaskar. We have last request from Mr. Shakti Pandey, former Executive Director from ONGC. This will be the last question, and then we move to Luncheon Network. I'm inviting him on stage.
Yeah.
Okay, thank you, Mr. Ajay. My question goes to Mr. Sandeep Dave. There are two questions, Mr. Dave. Number one is, do you produce only electricity out of the waste, or you produce some other value-added products as well, like hydrogen or ethanol? Number one. And my second question, let us finish question number one, then we still go to question number two.
Your question is correct. As I said, we produce primarily as an electricity, and we also develop other value-added products as a value chain. As I said, carbon dioxide. So it is another value chain that we are creating, but primarily it is a power that is being produced out of the municipal solid waste processing.
Thank you. My second question is that how much carbon dioxide you are supplying to ONGC? I'm asking this question because I was in Surat for about 15 to 20 years, and we are generating carbon dioxide in order of 1,200 tons per day during the sweetening of our sour gas coming from the offshore installations. But somehow, because of transportation problems starting from Surat to Ankleshwar, we could not materialize it. But in this context, I wanted to know how much carbon dioxide you are supplying ONGC for the enhanced oil recovery.
We have a projection to, actually we will start with a small project of 50 to 100 tons per day, but we have a capacity, we have a plan to go to 300 tons per day size of a plant, which in turn is around 100,000 tons per year.
So you are using only for the Ankleshwar project or Ahmedabad project?
Ahmedabad. Primarily Ahmedabad project to start with, because there are Vasana oil fields are close by, and there are oil fields which are into depleting and aging position around within 30 to 35 kilometers. So and incidentally it is close by, so it becomes easier for us to work on the pilot project.
Okay, that's right. Excellent presentation, and become very happy to listen about the work that you are doing and changing that waste to the energy it is rich of.
Thank you very much for your kind words, sir. Thank you.
Thank you. Thank you, Mr. Pandey. Moving on, I would like to thank Mr. Sandeep Dave and Mr. Suhas Baxi for joining us. It was a wonderful presentation to see a technology provider and a real innovator working together to make this vision possible of waste to energy in India. Thank you so much for joining us, and we look forward for your presence in the future sessions. And any more participants or attendees who really want to connect with both the officials, both the experts, please feel free to connect with them in the networking lounge, where they'll be more than happy to connect with you. Thank you so much, and we'll be back again with the next set of sessions at 2:15 sharp. Thank you so much for joining.
Thank you. Thank you so much for everything. Thank you.